On page 21, let's go over some things. First of all, number 3 says, on page 21, that's where we're starting. Number 3 says to use the standard deviation rule. Okay, so remember that the standard deviation rule is the mean plus 2 standard deviations. So on the quiz, it will specifically tell you in a problem to use the standard deviation rule, so you need to know what that is and show your calculation for that. Here, the upper fence was 163.82. How do you know if you have an upper outlier? Look at the maximum. Since the maximum is greater than 163.82, you have an upper outlier, okay? Lower fence is the mean minus 2 standard deviations. That's 94.18. Since the minimum is not lower than that, you want to know if the min is lower than that, it is not. So you do not have a lower outlier. So you have, in summary, at least one outlier. Now, I do want to kind of talk to you about how you come up with an answer that would be at least 2 outliers. The way you would say you know for sure you have at least 2 is if you had an upper outlier and you knew you had a lower outlier, so you had at least one upper and at least one lower, then you know for a fact you would have at least 2. So that's where that answer choice would come into play. All right, so this next one, number 4. The thing that you need to remember about that is that each quartile contains 25% of the data. So in order to answer these correctly, you have to know that because, for example, B says about 75% of the students scored at least an 82. Well, if you look at this 82, these 3 upper quartiles would make 75% of the data. So B is true. C says nearly half of the students scored an 82 or lower. Well, here's 82. Is this half of the students? Below it? No, it is just one quartile below it. So if it's just one quartile below it, it's just 25%. So that's the one that is false. Okay? We went over 5 yesterday. Did we go over 6? I think we did not.
Could you explain on number 4, the D or D?
D, 1 out of every 4 students. So that's 25% of students earned an A. Well, here's 90, and 25% of students earned an A, so that's why that's true. So not 5, but let's talk about, I do want to talk to you about number 6 because I want to renege on that this is not the smallest. This one here is the smallest. So let's talk about that. You remember that you have the smallest standard deviation if your data is closely clustered around the center. Does that make sense? You have the smallest amount of data if it is smallest standard deviation if it's clustered closely around the center. So I want to mention to you, what I did during first period was I took these 1, 2, 3, 4, 5, 6, 7, 8, 9, and I basically made a dot plot, a real quick dot plot out of all of these. So there was 1, 1, and 2, 2s, and 2, 3s, and so on, and 3, 4s, and then the most 5s, and so on, and it ended up being very symmetrical like this. Okay, so that one ended up being really nicely clustered around the center. And I had previously said that this problem was the smallest standard deviation, but it is not as nicely clustered around the center. It has all of this data, it does have all of this data up here. And so since it's not all nice and symmetrical around the center, then it doesn't compute the smallest standard deviation. So that's what that one ended up looking like. Okay? So this shape over here, which is very nice and symmetrical and unimodal, had a nice clustered closely around the center, hence a smaller standard deviation. Okay, so that one ended up being the smallest. Let me show you the one that ended up being the largest. If you take a look at this data and you made a dot plot of it, it had the data 2, 3, 4, 5, 6, 7, 8, 9. It had most of the largest amounts of data on the outside edges. Okay, And so then we had this going on. And so we had the most of the data on the outside edges. Hence, do you see that picture? Since that picture has got more of the data farther away from the center, that's the largest standard deviation. Yes?
But this one only goes from 2 to 9. Every single other one goes from 1.
I know, but did you do the actual computing?
No.
See, I did the actual computing and the other one ends up being smaller. I thought so too, but I guess that because
it's so stacked.
yeah, because it's so stacked over there. All right. Number 7, just FYI, this one ended up, okay, here's one thing that people did that threw them off on number 7. This gives you the 5-number summary. So 15 is the min, 32 is the Q1, 37 is the median, 42 is the Q3, and 59 is the max. And so there is more data than just those 5 points. So do not go put those 5 points, don't go put these in your calculator and calculate the 5-number summary. There's more data than that. This is the 5-number summary. So that is the min, Q1, median, Q3, max. So when you do your calculating, the upper fence is at 57. So what can you tell me about 59? You have at least one upper outlier. If the lower fence is 17, what can you tell me about 15? You have at least one lower. So if you have at least one upper and at least one lower, what do you have altogether? You have at least 2 outliers guaranteed, because you have at least one lower and at least one upper.
Could you say, like, at least one lower, at least one
You could just separate that, yes. At least one lower and at least one upper, that's fine. Yes?
Is S and X on calculators now?
Yes. So when you do your calculator, if you want to get your calculator stuff by hand, which I recommend, you know, you're doing your one variable stats after you put your things into list 1. Then your X bar is the mean of X, and the standard deviation you're looking for is the S of X, okay? Not the sigma, because we're dealing with samples. 8 is about, I'm going to just hold off on, well, it ends up being a Simpson's paradox problem, because overall, Lloyd looked bigger. But then individually, when you looked at each individual year, sorry, wrong. Overall, Fevela looked bigger. But when you did these individually, 2007, Lloyd was better. 2006, Lloyd was better. And 2005, Lloyd was better. So in the individual years, Lloyd was better. But overall, Fevela was better. That was Simpson's paradox. All right, let's go on to this warm-up. So you can see over on the board, over there, the items that, so everybody look on the board, sideboard. Those are the items that I will require for you to include on your box plot on your quiz. So let's look at those on this. So I want you to make sure you write down what the 5-number summary is. So I'm expecting you to write down the 5-number summary on your quiz. And so I highly recommend you going and putting all this data into your list and getting the 5-number summary from your calculator. That's probably going to be more accurate than you trying to figure that out yourself in one variable stats. All right, next thing, I want to see their fences and their values. So do go ahead and plot the fences and put how much they calculated out to be. What kind of fence do you use for a box plot? Or how do you calculate those fences? What rule? IQR or standard deviation? Always IQR, because we're getting the Q1 and Q3 and all that. Yes?
So if it were to have like an asterisk one outside of the fence, don't we put like the first one that's inside the fence? Like the first, isn't it like a
Yes. I'll tell you that in just a second. Okay, I also want you to make sure that you include the scale, which is this number line down here. Make sure you include that. Include your boxes and your box and your whiskers. Now let's talk about that. Suppose, and of course include any outliers. Suppose there was another piece of data here that was 105, where you had an outlier out here at 105, and of course that would have been your max. Okay, people, look. Your whisker does not cross the outlier fence. Your whisker will go to the next piece of data inside the fence. And then you have a break, and then you have your outlier hanging out there outside the fence. I know that there's extreme outlier fence at 3 IQRs out, but I'm not going to test you on that. There may be it on there, there may not be. I'm not worried about that, and I will not mark off if you don't do an asterisk instead of a dot, okay? If you want to do it correctly, fine. All right, and then finally, I want to see that you label your items. And what I mean by that is that you put what these things are, the min, Q1, median, Q3, and their values. Okay, so those are the items I'm going to be checking for on your box plot, and that's listed on the board over there for when you do your quiz. Now, this number 2, do you remember that, and I know that Andrew corrected this for me yesterday. Remember that we discussed this year, and I had to come back the next day, that when you have a dot plot, you actually do plot the individual pieces of data. You know, so a dot plot, remember, did look something like this, okay? As opposed to, remember this that I taught you? I said if you have something like from 50 to 55, then you just dropped your values inside there. I don't think this has a name. I think all of that is just a technique to make a histogram. Okay? This is the one that is technically a dot plot. Can you tell individual values from a dot plot? Yes. So therefore, I'm going to leave off this right here. A dot plot, I mean, a disadvantage would be that it's really cumbersome with large amounts of data and very big spread. Okay, that would be a disadvantage. But you can see individual data points on a dot plot. And you also would be able to see an outlier. You know, you could even calculate probably an outlier or something. All right, but dot plots and histograms are quicker and easier. And with a histogram, you cannot show individual data points. That is true. You cannot with the histogram. Okay? All right, so there's some information on that. Here are these shapes. You can use the numbers, the letters more than once. And here are these ones. This one is the bimodal and symmetric. This one was symmetric and uniform. Uniform being straight across. This one was skewed left and unimodal. And then this last one was skewed right and unimodal.
Would 5 not be multimodal as well?
No, with multimodal is reserved for 3 or more modes. Oh, no, yeah. 5 modes have to be kind of clear chunks of data. Like this looks like I have 2 subsets of data, like maybe children's shoe sizes and adult shoe sizes, okay? This would be separate modes. You wouldn't get all technical and say all these little teeny tiny things are different modes, okay?
What about?
So it's like one of their obvious.
Yes. Go ahead.
Never mind. So it's just unimodal.
Symmetric and uniform. Uniform.
So it's like one unit.
Yes. Like uniform has everybody the same. If y'all were all uniform, you were all the same. So those are about the same height. Okay. Questions there? Okay, moving on to the next page. We did talk about this yesterday, but real quickly, remember that 3 of our means and medians were all 53. 1 of them was not. So that was the first way that we addressed this. We found the one that looks like it was centered at 60, and that was picture D. So picture D was data set 2. Then all the rest were centered at 53. Then we looked at the standard deviations next. Okay, so we've used set 2 already. Standard deviations being least. Okay, so let me tell you, there are 2 things you are looking at to determine standard deviation size. 1, the more closely clustered it is to the center, what does that make it? Smaller. Okay, so more closely clustered to the center, that's a smaller standard deviation. But you have to also consider the scale at the bottom. Because this scale over here in B, picture B, only spans 8 values. This one in picture A spans 50 values, and this one in picture C spans 100 values. So that in itself changes the average distance from the mean. So that's why this least varied goes with B, and the most varied goes with C. Questions? That again is why 9 has the most varied one. Do you see this scaling here? That's 45 points as compared to 20 points over here. So the B was most varied, higher standard deviation. And finally, let's take a look at this. Do you remember our little trick? Mean, median, and mode. Okay? And so here is how you draw your inequality. Okay, see this inequality? I put all the data inside my inequality. So if it goes to the right like that, then that means my inequalities are shaped that way, and the mean is greater than the median. Okay, so there you go. Questions on that? Okay, then if you do it the other way, let's say we go this way to the left, then that would make our little inequalities go the other direction. So that would make our inequalities go to the left. If it goes to the left, our inequalities would go to the left, and the mean is less than the median. If they're about the same, if it's symmetrical, they're about the same value.
You said justify your answer. Do you just want us? Can we just do the sign thing like that, or do you want us to try like it's skewed right?
You could just write the inequality sign. Okay, number 11. This is the interquartile range outlier rule. You know that you have a lower outlier if it is a value below this lower fence. Q1 minus 1.5 IQRs. Q1 minus 1.5 IQRs. Okay? You have an upper outlier if you go above the upper fence. Q3 plus 1.5 IQRs. All right. This was the recent rule we learned this week. The rule we learned this week, the lower outlier rule was a value below mean minus 2 standard deviations. And the upper outlier is a value above the mean plus 2 standard deviations. Now, when do you know to use which rule, you might ask? You decide if you have skew or if you have symmetry.
Yeah, can you play us that song again?
So if you have skew, then you must choose to use median and IQR. So if you use median and IQR, which outlier rule are you going to use? The IQR outlier rule, which is the 1.5 IQRs. Okay. And then the rest of that song continues. Symmetry, standard deviation, and mean. So if you have symmetry, then you're going to use standard deviation and mean. Now, let me tell you something, people. All day long, I was not happy with the fact that people did not catch on to this instructions. Describe the distribution, shape and outliers, center and spread. I mean, hello, we wore silly socks yesterday to celebrate. Describe the distribution with your socks. So you were supposed to have done not just shape, but shape, outlier, center, and spread. So let's talk about it. You first say, hey, look, that looks pretty unimodal and symmetric. That then guides the rest of what you do. So guess what? I have symmetry, standard deviation, and mean. So therefore, hey, listen, shh. Therefore, when I do my spread, I say the standard deviation is this value. When I do my center, I say the mean is this value. So I'm specifically stating standard deviation is this, mean is this. Furthermore, if I'm using mean and standard deviation, then what rules do you think it would make sense to use? The IQR rule or the standard deviation rule? The standard deviation rule, mean plus 2 standard deviation rules, mean minus. And when we did that, we did have one upper and one lower. So if we were to say we have one upper and one lower, what do we really have? At least 2 outliers altogether. All right, that is the end of going over all of the warm-up stuff.
What if you can't
Yes?
tell if it's skewed or skewed?
It's intended, it should be pretty obvious. I mean, it's never, hey, this is a good question. I did get this all day. Listen, you know, how can you tell if this is symmetric? I mean, well, it's not perfectly symmetrical. You are not, in real life data, you're not going to have perfect symmetry. You just have to kind of say, is it closer to being symmetric than a whacked out skewed one? You know, even your body is not perfectly symmetrical. Yes?
For center, all you have to put is mean, or
You put mean is this or median is this, depending on which one you use. All right, here we go, quiz. Oh, for homework, listen up. For homework, you have to cut up your cards and put them in a baggie.
That's all?
You do not have to do anything with them, no work, except for cutting them up.
I'm game.